Hi students, so in this lecture we discussed about Floyd's algorithm. Floyd's algorithm definition is used to find the shortest path between every pair of vertices in a weighted directed graph, that is a digraph. So for this we are using the distance matrix d0 to dn. For finding the distance matrix we use the formula, that is k will be of any intermediate vertex of I comma j, and finding the minimum among the given value. Either the given value is small means we keep as it is. If it is an infinity means we make it as sum of ik plus kg. So this algorithm, so here we will take the input as the weighted graph W with no negative length cycle, and our output is finding the distance matrix of the shortest path length. We will assign W that to be D, and for intermediate thing we use this looping statement for ith row and jth column. With the help of these formula we find all the rows as well as a column and make the path with minimum distance and return that value in D. So here we are having a weighted graph and that graph adjacency matrix will be defined with its original weight. If there is a path, the value will be assigned there. If there is no path, that may be defined as infinity. And if the self loop will be presented as 0. So we will start with a given input value, that is adjacency matrix D0. Here we have to check 5 in the second row and 1 will be in the first row. So we sum up to make it as a 6. Similarly 3 plus 1, 4. And this will become the input for the next scanning. That is the second row, second column, and we will check whether any other changes will be happen. So 5 plus 2 is equal to 7, so that will be reflected here. So this reflection will be changed and move to the next row, third column, and in the third row, third column, maximum there is no change, and we have to move from fourth row, fourth column, and here itself we can find many number of changes. So here 2 plus 1 which is equal to 3 here, 4 plus 1 which is equal to 5 here, 6 plus 4 which is equal to 10, and 2 plus 4 which is equal to 6. So these are the indirect weight, that is the vertices to pass from A, B, C, D, etc. So we find the final matrix, that is a distance matrix for the given input distance matrix D0. So this is the Floyd's algorithm. So we can get the input as well as the output. So we will check from A to B is a direct wedge B. A to C there is no direct wedge. So what we have to do is A to D we have to check this. Indirectly we will go to that value. A to D is 6. So we have to do is A to D is direct edge is 1. Sorry, B to D we have to go to B to D. There is no direct edge. So we have to move through A. B to A is 5. 5 plus 1 6. So 6 will be reflected here. Similarly, all the vertices may be racers. So the time taken for computing this Floyd's algorithm is theta of nq, and the spaces depends upon the matrix can be written over the predecessors. So the note here, the important point note here is it works on graph with a negative edge but without negative circle. I think this lecture will be useful for you. So these are some of the reference books we follow. Thank you so much for your patient listening. Thank you.